Hi everyone. In today's video, I will be going over the Unit 2 Transformations Review Sheet. This is for our test. So let's go ahead and get started. On the front here, we've got 10 graphs. And the goal is to match each graph to its name and its equation. So some students get confused on what exactly they're supposed to do here. Notice on each graph, above each graph, there's two blanks. One blank you're going to put the name, and the other blank you're going to put the equation. Just write the corresponding letter. Don't write out the whole thing. And as you can see, we've got 10 of them here, and we only have 5 options each. So we are going to repeat each of these, and I believe we do use each option twice total. So just keep that in mind. All right, number 1. This is the disco right shape. It looks like disco arms. Hopefully you recognize that as the cubic function. So we're going to put the letter X. And then in equation form, the cubic equation has the cubed in it. So I'm going to write D next to that. And if you want to make it easier, we can go ahead and match the names up with the equations. It'll make this go just a little faster. So I'm actually going to do that as I go. So we've got cubic here. I've already identified that. So I'm going to write cubic next to it. So, because I'm going to use that again, so it's just helpful to already have that matched up. All right, next one. This one's upside down from what you're originally used to seeing it. So this may look a little confusing at first if you don't recognize it. I'm going to go ahead and show you the correct way that this is supposed to look. And this is the reflection of number 8. So it's the same shape, but it's upside down. So this here is the square root function. So Z. And I'm going to go ahead and put it here since I've already shown you the other one. So you know what it's supposed to look like. So now we're going to go over here and find the square root equation. And that is equation B, square root. So B is going to go with Z. There are so many ways to go about this problem. You could go one by one like I'm doing it, or once you find the first one, you can try and find the other one of that same type so you already have those letters taken care of. So that would be another strategy to do as well. Number 3 is the reflection of number 1. So it's cubic, but notice the arms are going the wrong way. So cubic is supposed to go up to the right, and this one goes up to the left. So these are both cubic, just reflections. So I'm going to use those same letters, X and D. Next, here we have the V shape. Again, it's upside down. The way it's supposed to look is in number 10. This is the proper V shape, the absolute value. So that is option W. And then let's find the absolute value equation. It's going to be C. Option C. And then the reason I chose 10 is because 10 and 4 are both the same type. They're just reflections again. So I'll go ahead and fill in those letters here as well. All right, I feel like I've just gone backwards this whole time, so I apologize if I'm jumping around a little too much. All right, number 5. Here we have the U shape. This is the classic U shape we're looking for. So this is the quadratic equation. So this is V. And the quadratic equation is the squared. So we have V and A. Now, if you wanted to, you could go to the other 3 graphs I haven't chosen yet and try to find the one that matches this, for instance. That's a good strategy. I'm just going to keep going in order. Number 6, this one is also flipped from what you're used to seeing it, but the shape is uncanny. It's undeniable. So this is some of us called it a tilted smile. We also got the name boomerang thrown out there. I liked both of those. The exponential equation. So option Y. And the exponential equation is the one I haven't used, E. So option E goes on number 6. We have 2 graphs left. I have already used all the letters at least once, so these next 2 are going to be repeats. Number 7, this is the U shape, but it's upside down, so it matches with number 5. They're just reflections, so it's going to use the same letters, V and A. Lastly, number 9. This is the correct direction of the exponential. It's supposed to be going up to the right and not to the left, so these are reflected. So my letters are Y and E. And yeah, that is the first big problem, but the first 10 fully completed, all matched up with the names of their equations and their graphs as well. All right, number 11. Here we have a nice graph, and we're going to answer these questions, identify these characteristics about this specific graph. So a couple things. Hopefully you're able to identify the type of graph. We do give you the equation here, but by the shape, this is a V for value as an absolute value. And just notice that we can see the bottom of the graph. It's right here. If we had more plane underneath it, it would be completely blank. So just keep that in mind. You can see pretty much the whole graph. It is not cut off really. Identify the vertex. So this is the starting point. And let's get specific here. A vertex, it's either in the quadratic, the U shape, or the V shape. It's that point at the very bottom. That's what we call the vertex. So that's what we're looking for here. So on our picture, clearly that's this point down here. Now again, you have to use the full coordinate point. This is not just a number. So this is 2, -3. State the domain. Domain, these are your x values, and you move from left to right when you identify domain. So start by finding the left side of your graph. That's right here. We have an arrow pointing to the left, so the domain starts at -infinity. Then we follow the graph. It's a solid line, which is what we want. And then we end here on the right at another arrow that's going to the right to +infinity. So this is your classic -infinity to +infinity graph. State the range. These are the y values, and you move from bottom to top when you're finding the range. So you want to ask, how low does it go? How low does the graph go? Again, this point here is the bottom of the graph. I know it's kind of hard to tell, like maybe there could be something else. But if I had more plane under here, I can guarantee you that it would be just blank. Nothing else under this point. So the bottom of the graph is here at -3. Again, now we're looking at y-axis only. So -3 is as low as it goes. And this is a solid point, so it gets a bracket. And then from here, we follow the graph up, and both of these are nice solid graph and line. That's what we want. And then we end at arrows going up both ways. So we're going to +infinity, parenthesis. 2 more. X-intercepts, this is where the graph crosses the x-axis. So we have the x-axis, and then we have our graph here. It crosses the x-axis twice, at -1 and at 5. So these are your x-intercepts. I'm going to mark those on the graph. So when we say x-intercepts, that's what we're talking about. Now, reminder, it's very easy to mess this up. When you write your answer, if you write -1 and 5, it's wrong. We're asking for points here. I want both points. Next, make sure that the x value, the number, goes in the x spot. So we have -1 and 5. And then 0 goes in the other spot because y is 0. Make sure you put the numbers in the point in the correct order. A lot of students will have the right numbers, but they will switch them. Again, you will lose points. You will not get credit if they're in the wrong order. That matters. Lastly, we need to identify the y-intercept. Y-intercept, same concept. It's where the graph crosses the y-axis. So that's going to be here at -1. Again, we're writing a point. We're not just writing the number. And then this time, this is the y value. So -1 goes here, and then the 0 is in the x's spot. Make sure you write it correctly. All right, that's all for the front side. Next page. Another one of these, just with a different type of graph. Given the graph to the far right, describe the following characteristics. Identify the vertex. So again, hopefully by the shape, you can tell that this is a quadratic. And this is that U-shaped graph, but it's upside down. Our vertex in this case is going to be right here. So again, the normal graph of this would look like that. So it's upside down. And this we call quadratic. Just keeping that on our radar. And then I will make a note that it's reflected. So it's this, but flipped over. So it flipped upside down. So that's why it looks like it's going the wrong way. All right, vertex is the point I have already put a point on here. That's going to be 1, 4. Domain. So again, domain, your x values, and you go from left to right to find it. So we start at the left side of our graph, and we have an arrow here. Yes, it's moving down, but it is going to the left. It's going down and left. So this arrow is going this way to -infinity. So -infinity is the start of our domain. And then we follow the graph. It's a nice solid line. And then we stop here. Add another arrow. Yes, it's going down, but it's going down and right like that. So it is moving to -infinity. Or sorry, positive infinity. It's moving to the right towards positive infinity. You can put the plus there, or you cannot. Choice is yours. Range. So this time we're looking at the y values, and we go from bottom to top. This time we look at the bottom of the graph. So we're asking how low does it go? The bottom of the graph. Both arrows are going down to -infinity. So the range starts at -infinity. And then we follow the graph up, nice solid line, until we end at this point here. This is the top of the graph. And it is at 4. And since it's a point, we use a bracket. So our range is -infinity to 4. X-intercepts, again, we look at our graph for where it crosses the x-axis, x-intercepts, x-axis. So we got 2 points, 1, 2. So our points are -1, 0, and 3, 0. One more, the y-intercept. Y-intercept, y-axis. Here's our line, here's the y-axis, here's where it crosses. Again, make sure you write the point correctly. This is the point 0, 3. That's number 12. Number 13, this one's a little trickier just because exponentials are handled a bit differently. Identify, or given the graph to the far right, describe the following characteristics. A, identify the asymptote. So exponentials are special because, so let me write this first. This is called the exponential. And its shape is what you see here. You can either see it as a boomerang or a tilted smile, and then it has an asymptote underneath it. So this line here is special and specific to this function. So you look at the graph, and you see that as this graph goes to the left, it very quickly starts to like flatten out like it's going to stop. And it's not. It does slowly move down just the smallest amount. But it looks like it's flattening out to us. So where the flattening happens, that's the asymptote. It's doing this because it's avoiding the asymptote. So right here through 5 is the asymptote. That's the boundary. So the asymptote, the proper way to write this, it's through 5 on the y-axis. So this is y equals 5. That's the proper way to write this answer. Next, we state the domain. Again, domain are your x values, and we move from left to right. Start on the left. We have an arrow here, and it's going to the left, clearly to negative infinity. And then we follow the graph to the right. And then we hit this arrow. And while it is slowly moving up, it is also moving up and right. It's going this way to positive infinity. State the range. So the range, these are your y values from bottom to top. So first you ask yourself, how low does it go? Here's the graph. Now this asymptote acts as a boundary. Think of like security or like a locked door. It won't let this line go past it. This is stopping it from moving it anywhere else. So it's saying you can't be 5 and you can't be less than 5. So we're stopping you at 5. So 5 is the lowest part of the graph. However, this line, remember, cannot be touched, let alone crossed. So this line can never actually get to 5. It's going to get as close as possible. So since it can't actually get to 5, we're going to put a parenthesis around it, not a bracket. 5 is not included, but that's our starting point. And then basically from there, we can go up and go as high as we want. We just can't go under 5. So we very quickly reach this arrow, which is quickly moving up to positive infinity. Next, we have the x-intercepts. Again, x-intercepts, x-axis. Our graph is up here, and here's the x-axis. And our graph is being blocked, held up here by the 5. It will not go under the 5, let alone touch the x-axis. There are no x-intercepts, so we will write none. Y-intercept, y-axis, it crosses right here at the 6. So our point here is 0, 6. Number 14, graphing. Graph the following function. F of x equals x plus 3 squared minus 7. So we just have to graph it. When you graph it, you find the vertex, make a t-chart, get your points, and then plot them. So we need to find the vertex first. When you find the vertex, you have to first identify left and right, or up and down, first and foremost. So let's do that. X plus 3. Now remember, this you read as the opposite. Remember, x lies. X's lie. Sure, you could relate to that experience. X's lie to you. So if this looks like right 3, it's actually left 3. Now the negative 7, this is a y. Y will tell you the truth. So this looks like minus 7, down 7. It is down 7. This will not lie to your face like your x will. Once you identify left, right, up, down, now you can make the vertex. So left 3, that's a negative movement. So at this point, it is helpful to ignore the equation because some students get confused when they look at it. Left 3, this is a negative movement, so minus 3. Left is a negative movement. Down 7 is also a negative movement, so minus 7. This is our vertex. Now we come over here and make our t-chart. Vertex goes in the middle. -3, -7. So above it, I'm going to go 2 lower than -3. That's -4 and -5. And then under it, I'm going to go 2 higher. -2, -1. And then I'm going to go ahead above it and write out my equation again. That's where I'm going to put my points into. And I'm just going to replace f of x with a y. Y equals x plus 3 squared minus 7. From here, I'm going to do my best to fit all my work on this paper. I'm going to one at a time plug these numbers into the equation and get an answer. So we do this 4 times. So -5 first. We have y equals, in parentheses, -5 is going to go in x's place. -5 plus 3 squared minus 7. Now when you're going through this, remember to use PEMDAS to get your answer. Don't just go in the order you want. So PEMDAS P is for parentheses. So inside the parentheses, we have -5 plus 3. Let's do that first. -5 plus 3 is -2 squared minus 7. Next is exponents. -2 squared. Be careful here. I'm going to say it again. I've said it many times in class. If you type this in your calculator without the parentheses, it will give you the wrong answer. This is wrong. It should not be -4. So let me do it with the parentheses. Now it's right. It's +4. 4 minus 7. And 4 minus 7, we know that's -3. You can use your calculator to help you with this. Just use it carefully. This is why we practice writing things correctly, because if you write them correctly, you'll more than likely type them in the calculator correctly. That's important. Okay? So we've got -5, -3. 3 more times. X equals -4. Y equals, in parentheses, -4 plus 3 squared minus 7. I'm going to repeat the same steps. -4 plus 3, that's -1 squared minus 7. -1 squared is +1. Be careful with those negatives. Minus 7 is -6. So then we have -4, -6. Two more. X equals, now I'm at -2. Y equals, in parentheses, -2 plus 3 squared minus 7. Parentheses first, -2 plus 3 is +1 squared minus 7. 1 squared is 1. And 1 minus 7 is -6. One more time. X equals -1. So we have y equals, in parentheses, -1 plus 3 squared minus 7. -1 plus 3 is positive 2 squared minus 7. 2 squared, 2 times 2, that's 4. And 4 minus 7 is -3. Now notice my numbers repeat here as I go. This is called symmetry. This is a symmetric graph. It's supposed to do this on this particular problem, so we shouldn't be too shocked about that. Now when you go to graph, keep in mind what your graph is going to look like. Let's go back to the original equation. We have a squared in here. This is quadratic. So let's keep that in mind. This is quadratic. So that means we should have a U shape to our graph. It's just helpful to have an image in your mind as you're graphing. All right, we're just going to plot these 5 points. -5, -3. So we go left 5. Yep. And then down 3. -4, -6. Left 4. Down 6. -3, -7. So we go left 3, down 7. And then -2, -6. Left 2, down 6. And then -1, -3. Left 1, down 3. And then again, hopefully you can already see the U shape forming. We're going to fill this in. Make it look like a U. Don't try to make it look like a V. This should look like a U. And there you have it. That's the completed graph. Next page, number 15. We have another graph, but this will be our last graph that we'll have to do by hand. So only 2 of them. That's not too bad. At least I hope you don't think so. Next, we have number 15, graph the following function. F of x equals 2 times the absolute value of x plus 6. So this one's a bit more obvious. This is absolute value. And V for value. That's the shape. Keep that in mind. All right, we're going to do the same process. So for our vertex, remember, you need to identify left and right, up and down. That will tell you the vertex. So this 2 in front is not going to affect that decision. So again, we find the x. Remember, x's lie. So this looks like right 6. It's actually left 6. And then we don't have anything at the end here for up and down. So this is it. So my vertex, left 6, that's minus 6. And then remember, we had no up or down. And of course, I'm going to need that part of the graph. That's okay. We had no up or down. So -6 is 0 is my vertex. Let's make the table. T-chart. Now the good news is there's a little less going on in this equation, so these calculations are going to be a bit shorter. My vertex, -6, 0, goes in the middle. Going to go 2 smaller than negative 6, so negative 7, negative 8, and 2 bigger. Negative 5, negative 4. Now I'm just going to get what these are. I'm going to rewrite the equation. Y equals 2 times the absolute value of x plus 6. All right, one by one, I'm going to do this 4 times. First, we have x equals negative 8. Y equals 2 times the absolute value, negative 8 plus 6. Remember, we can't drop this absolute value until we get one number in here and we see what the absolute value is. Also, you cannot put this in the calculator, as tempting as it is. There is no absolute value symbol in here. Can't do it. So we have 2, don't put parentheses, absolute value. And remember, we're following PEMDAS still. Let me write that as a reminder. So these absolute value signs act like parentheses. They serve a similar purpose. So we're going to do what's inside of them first. Negative 8 plus 6 is negative 2. Now next you need to ask yourself, what is this equal to? Absolute value of negative 2 is positive 2. So it's going to come out in parentheses. Bring down the 2. This is 2 times 2, which is 4. So negative 8, 4 is our answer. I'm going to make this work somehow. Just might be scrapped for space here. Okay. Next we have negative 7. I'm going to repeat that. Y equals 2 times the absolute value of negative 7 plus 6 to absolute value. We're going to do what's inside the absolute value first. Negative 7 plus 6 is negative 1. Then we have 2, and then we ask ourselves, what is this? What is the absolute value of negative 1? It is positive 1. 2 times 1 is 2. 2 more times. Next, we're going to do x equals negative 5. So we have y equals 2 times the absolute value of negative 5 plus 6 and then we have 2 times the absolute value. Negative 5 plus 6 is positive 1. And then again we ask ourselves, what is this? The absolute value of 1 is 1. So this is 2 times 1, which is 2. All right, we got one more. X equals negative 4. We have y equals 2 times the absolute value of negative 4 plus 6. 2 times the absolute value. Negative 4 plus 6, that's positive 2. And then I think I can make this work. 2 times the absolute value of 2 is 2. Again, we ask ourselves, what is this? Absolute value of 2 is 2. And 2 times 2 is 4. There are my 5 nice points. I'm going to graph them. So we have negative 8, 4. So I'm going to go left 8 and up 4. Negative 7, 2, left 7, and up 2. Negative 6, 0, that's just left 6. Negative 5, 2. Left 5, up 2. And then negative 4, 4. Left 4, up 4. And again, we're going for that V shape this time. Hopefully that's very clear in the graph I've made. Again, just make it look like a V. It doesn't have to be perfect, but it has to be obvious that you're not trying to make a U. I'm going to stop it there since I'm going to run into my writing. It's okay if one is longer than the other, that's fine. All right, you can celebrate a little bit because we're done with graphing for, at least graphing by hand for the rest of the study guide, so that's exciting. Number 16. Consider the graph shown. Which of the following equations could represent this graph? So here we have our 4 options as equations, and it really helps to look at the graph and ask ourselves, what kind of graph is this? Hopefully you recognize the shape here. This is the exponential. We can add arrows to the end if that helps you in any way. So hopefully you remember exponentials have a very special part to the graph that the other 4 do not, and that is the asymptote. This line here. So let's find that first in our graph. It's where it's starting to straighten. So just draw it in and makes your graph easier to see. So let's figure out which number this is going through. Here, 2, negative 2. So this is the line y equals negative 2. From here, you want the equation that has negative 2 at the end. So A has negative 4 at the end. B has negative 2 at the end. That's what we're looking for. That is the correct answer. C has a positive 2 at the end. And Y has positive 4 at the end. You want this one. That's how you can tell. It's that straightforward. So the correct answer is B. All right, I think that was it for graphs. There are going to be 2 more graphing problems at the end, but they're a different kind of graphing problem, if you will. For now, let's stick with just some writing things. 17. Write the equation of the function with the following transformations from the parent function, f of x equals x squared. So this is a very wordy problem, but it's not too bad when you read it. It's a lot, but when you actually understand it, it's really not that complicated. So we're wanting to write an equation here, and it originally looked like just x squared. But now we want to make all these changes to it, and our general form is f of x equals a times x minus h squared plus k. So each of these changes, transformations, is going to go into a spot. And we just need to write how it's going to change, and then we're going to make the new equation. Shift of 4 units to the right and 2 units down. A reflection over the x-axis and a vertical compression of a half. So I'm going to color code these to kind of help me out here. So A, I like to always make that one red. And then I go back and forth on these. I believe x minus h is left or right. And then k is up or down, green. Okay. So we have 4 units to the right. So they actually mixed them up on us. So these are not in order. So these are going to make it a bit tough. 4 units to the right. So the plus, oop, I already messed it up. Hang on. Wrong color. 4 units to the right. So under the middle part, the purple part here, this is right 4. Now in the equation, we write this as x, because it goes inside with the x. And remember, x lies. So right 4 is not plus 4, it's actually minus 4. So that's how it's going to look like when I make the equation, this equation here. Okay, next 2 units down, that's the k, this is up or down. So 2 units down. So this is down 2. So in the equation, I'm going to write that as plus 2. And then lastly, a reflection over the x-axis and a vertical compression of a half. All of this is the a value. So a reflection over the x-axis and a vertical compression of a half. So reflection means a is negative. And then also the vertical compression of a half. A is a half. So if I put these two details together, a is negative and it's a half, then that means a equals negative 1/2. Just put them together. Negative 1/2. Okay, let's write our final equation. So I'm going to follow the template, and then I'm going to put my numbers in where they go. So I have f of x is equal to, a is negative 1/2. I'll write it all in black. I think if I do the color coding again, it's just going to be a little hard to look at. So negative 1/2. And then in this, I already put, I'm going to write x minus 4, and then I'll go ahead and write the squared in the purple color coding. That's a very easy detail to forget. X minus 4 squared. Got that? Plus k is plus 2. This is our completed answer. So you really want to take your time with this one. Make sure you pull out all the transformations. You can put them where they're supposed to go, and you use the right numbers, symbols, all of that. That is all important. And don't forget the squared, for instance. If you drop this on the test, it's a -1 on the problem. You don't want to miss 1 point because you forgot to put the squared. It happens all the time. All right, number 18. Given the following function, f of x equals 5 times the square root of x plus 7 plus 4. State all the transformations. So this time we're just looking at the equation and noticing what the transformations are. So let's go through them one by one. So first in the front we've got the 5. That is the a value. A equals 5. So now what does that mean? That means we have a stretch of 5. So remember, when we have a number less than 1, typically a fraction, we call it a compression. And then if you have a number bigger than 1, it's called a stretch. Next, under the square root, I've got x plus 7. X plus 7. Remember, this lies to you. This is not right 7. This is left 7. And then lastly, I've got the plus 4 at the end. Plus 4. Again, just ask yourself, what does that mean? This means up 4. So it said state all transformations. These 3 answers on the right-hand side, these are my transformations. I am done. One more time, number 19. Back up real quick. I just noticed up here, I said down 2. This is supposed to be a -2, so let me fix that. That is supposed to be a -2. I am so sorry about that. Okay, so number 17, fix that down to, this should be a -2. I saw the plus, that is exactly why I wrote plus. So that is my bad. Okay, number 19. Given the following function, f of x equals x minus 2 squared plus 1, state all transformations. So it's just another one of number 18. There's actually less going on here, so this one's going to be a little easier. There is no number in front, so we don't have to worry about a. We do have a number with the x minus 2. Again, this looks like left. It's actually right. So x is going to lie to you. This is right 2. And then at the end, we have the plus 1. And this is up 1. And that is all for number 19. Flip it on over to the back side, finish this up. Number 20. Which equation shows the transformation of 8 units up, 7 units to the left, and a reflection over the x-axis of the parent function? And then here's the given equation. So we just need to figure out which one of these has all of that stuff. So, again, we're just going to go through them one by one. And I'm going to color code like I did before. A is red. X minus h is purple. And then the plus k is green. So we have 8 units up, that is the k. 8 units up, that is going to be plus 8 up, plus 8. Didn't mess that up this time. 7 units to the left. So left 7. That is going to be x, remember it's the opposite, plus 7. X is going to lie. This looks like right, this is left. And a reflection over the x-axis. A reflection over the x-axis means A is negative. And we're not given a number for A, so that's all we have to put is a negative there. So let's take a look and see what our answer choices are. A, -2 times x minus 7 cubed plus 8. I can already rule this one out because it's got a -2 in front. We were not told a stretch of -2. So this is wrong. The x minus 7 is wrong. It should be plus 7. The plus 8 is right. So clearly it is not A. B, we've got a negative in front. Good so far. X plus 7 and plus 8. It passes everything. So I'm still going to check C and D, but I am pretty sure B is correct. This is just a good test-taking strategy. There have been many times where I have thought that I had the right answer, but then when I read the other answer choices, I realized that I was wrong. So it doesn't hurt to check the other answer choices, even if you think you're correct. C, we don't have a negative in front, so that's not a good sign. And then x minus 8, that is the wrong number. It should be plus 7. And then in plus 8, instead of plus 8, they have plus 7. So C is not it either. Lastly, D, we have the negative in front. That's what we need. But again, the numbers are switched. It should be plus 7, plus 8. Those are wrong. So B is the correct answer. 21. Write the equation that shows the transformation of 5 units to the left and 2 units down of the parent function. And then here's the equation I'm going to go off of. Again, A is red. I'm going to use purple for the x minus h. And then green for the plus k. So 5 units to the left, that's the purple part. So I'm going to write that here. 5 units to the left, so left 5. In the equation, and we have a square root here, so I'm going to put it under the square root. We have x, and then again we do the opposite, plus 5. This looks like right, it's actually left because x lies. X's lie. 2 units down, that is what I do in green. Up and down is green. 2 units down. So we have down 2. So that's going to be minus 2. We were not given any information on A, so don't even worry about the A. Don't write A in your equation, like the letter A. If there's no A, drop it. Don't write it down at all. Let's put that all together and make an equation. So I have f of x equals no A, don't write it. Square root of x plus 5 minus 2. That's it. Sometimes it's a very simple answer like that. Done with 21. 22. Given the following function, f of x equals negative 1/2 absolute value of x plus 8 plus 1, state the transformations. There's a lot to read here, so I strongly recommend you look at the equation, figure out the transformations first, then go looking for your answer. If you try to read through and match what is said here and what it looks like here, you're probably going to have a higher chance of making a mistake. So let's go through it. So negative 1/2, that number in front, that is the A value. And I'm going to go ahead and write what that means here. So this is reflection. So the negative is reflection. 1/2, this is a compression of 1/2. Next, we have the x plus part, the x plus 8. Again, this looks like the opposite. This looks like right. It's actually left 8. And then lastly, the plus 1 at the end is up 1. So these are the 1, 2, 3, 4 transformations I'm looking for in my answer choices. Read them carefully. Shift 8 units left, yes. And shift 1 unit up, yep. Reflect over the x-axis, yep. And compression of 1/2. I don't see anything wrong with this answer. I'm pretty sure this is right. Again, go through the others and make sure that they are wrong before you continue. Shift 8 units down, no. 1 unit to the right, nope. So they switch these numbers is what they're doing. Reflect over the x-axis, yep. Stretch of 1/2. Stretch is actually incorrect. It should be compression. But I've already found enough reason to say B is wrong. Shift 8 units to the left, yes. And shift 2 units up, no. That's the wrong number. Compression of 1/2, yes. They're missing the reflection. C is wrong. D, shift 8 units to the up. Shift 8 units up, no. 2 units to the left, nope. Compression of 2, no. Where did 2 come from? Reflect over the y-axis. Not that you guys would have recognized that, but the y-axis is the wrong axis completely. D has a lot of problems. And by the way, when you find one thing wrong with it, that's good enough to say, okay, this isn't the answer, but I am going through all the mistakes here. So A, 22, is the answer. Also, backtracking again, I'm going to write B in the blank here for 20. Please don't be the person like I was and just box the right answer. Like, it helps me if you write the answer in the blank. Make sure they are the same answer. Don't put one here and circle another one. All right, we're almost done. 23. Given the following function, f of x equals 3 times x minus 1 cubed plus 4. State the transformations. So again, let's just go through and dissect what is happening here. 3, the number in front. A equals 3. Again, just ask yourself, what is this doing to the equation? The number, this is bigger than 1, so this is a stretch of 3. Make sure you use stretch and compression correctly. If you put compression, it's going to be wrong. Next, inside here, we have x minus 1. Again, x lies to you. This is not left 1. This is right 1. And then at the end here, we have plus 4. This tells the truth. This is up 4. That's it. So these three are the answers, but if you write all this, you're going to be just fine. Lastly, graphs to equations. Figure out the equation just by looking at the graph. Given the graphs, write the equation. So, first off, I'm going to write down the generic equation for this. And that should be somewhere else in the study guide. Give me just a moment. I'm having a hard time locating it. Okay, I'm not seeing this exact one being offered, so I will just have to give it to you. So, write the equation. So first off, you got to identify what function do I have here. Oh, you know what? It's on the very front page. That's where it's at. These. You're going to need these to help you with this problem. And they will be on the front page of your test too, just like this. So first off, figure out which type of graph you have, and this front page will actually help you figure that out if you're struggling. This is an absolute value. It's the V, but upside down. That's how I can tell. So I'm going to copy down the absolute value equation right here. F of x equals absolute value x minus h plus k. And then I am also going to write the a in front. It's not included here, but that is important. Next, I'm going to go through and I'm going to figure out each part of the equation for this problem. So, first off, let's go ahead and do A. So first off, this is upside down, so there is a reflection. So first, we're going to start first and foremost with a negative. I'm going to go and put that in there. A is negative. Now I need to figure out what number A is. A could just be 1, or A could be a different number. Now absolute value, it's very easy to tell because absolute value uses slope. So we're going to put our point on the vertex. Next, going through here, I need to find the next good point right here. So we're just going to follow slope. And, yeah. So this is rise over run. So we go down to, right 1, 2, 3, right 3. So this is down to right 3. So negative 2 plus 3. So we know that A equals negative 2/3. I already have the negative there. Don't write an extra negative. That is the same negative. So we have negative 2/3. That's my A value. Next, inside of the absolute value, that is the left or right movement. So I just want to clarify before it starts at 0, 0. So you have to know whenever you're trying to figure out left or right, or up or down, your graph started here at 0, 0. And we're following the vertex. How did the vertex change? So that was the before. And I put a purple dot on top of it because I used the purple and the red for different purposes. After, we are at 3, 4. So this movement from here to here is going to tell me how I moved. So first we're doing left to right. So we moved right 3. right 3. So this is x, remember it's the opposite, minus 3 inside of the absolute value. So I'm going to write that in next. So remember, x lies to you. This looks like left. It is right. Lastly, we move right 3 and we moved up 4. So we're going to have a plus 4 at the end of that equation. So this combination here is my full equation. Negative 2/3 absolute value of x minus 3 plus 4. That is the full equation. One more. First off, you need to recognize what this is. This is a quadratic. And again, it helps to write out the basic equation. That is this one here. We're going to put an a in front of it, otherwise it's good. F of x equals a times x minus h squared plus k. Now we fill in everything. And I have a little less room than I did last time. So let's start with A. A. There's no reflection. This is going the correct way. It's going up. So we started our vertex. Now this might be confusing because this is backwards from what I did on the other graph. You technically can use the next nice point here, so I'm going to keep it consistent. So the next nice point here is this one right here. So we go up 3 and right 1. Up 3, right 1. So A equals 1, nope, rise over run, 3 over 1. So A is 3. So we're going to put that at the beginning. We have a 3 in the front. And then from here, I'm going to set up the rest of this. I'm going to have an x, and then I'm going to have a squared. Okay, I need to figure out what number goes inside the parentheses. So we find the origin here, and then we ended up here. So, before was at 0, 0. And then after was at 1, 2, 3, 4, 2. So, in here, from 0, 0 to 4, 2, we move right 4. So this is minus 4. Again, this looks like left 4. It's actually right 4. You're going to do the opposite in the sign. Right 4 up 2. So plus 2. And that is my final equation for that one. And that is it for the study guide. I hope that this was helpful. I'm sure a couple of the problems probably caught you off guard. I promise with more practice, they will make a lot more sense. If you have any additional questions, or if you've done some problems and you want a few extra problems for practice, you just really want some more practice with some of these types, let me know which types of problems you want to see more of, and I can definitely give you some more examples. Otherwise, I hope this video was really helpful, and I hope you have a wonderful day. Bye!